Okay, guys, this is the midterm. I'm gonna go over it really quick to solve the problem. So here, in number one, they're asking you the probability of A equals 0.4, and probability of B should be here, 0.6. And the intersection of the set is empty, so that means the probability of A, remember this is N, that means intersection, right? It's 0, right? Are sets A and B mutually exclusive? Well, think about it. This is two disjoint events, right? So there's no overlap, therefore the intersection is 0. So are they mutually exclusive? Yes, because there's no overlap, right? So yes, they are mutually exclusive. Okay. 2, the probability of the complement is 1 minus the probability of A. So that's 1 minus 0.4. This is 0.6. Probability of B complement is 1 minus the probability of B. That's 1 minus 0.6, which is 0.4. The union, this is the general addition rule, probability of A plus probability of B minus the intersection A intersection B. Sometimes you will see this written this way. That means the same thing, okay? If you see A, B like this, that means that's the same thing as intersection. But we know the intersection here is 0, so we just need to add the probabilities of A and B. So 0.4 plus 0.6, that's a 1, okay? That's how you do that one. Next one. The next one is asking you find the probability of, well, they said let X, then they know the number of unique visitors to a website in a month with the following probability. So probability of greater than 50 is 1 minus the probability of X is less or equal than 50. So since we don't have that probability, we kind of use the probability that is kind of very close to that. So that's 1, right? So this is 1 minus the probability of 1 equals 0. Probability of X is less or equal than the random variable, and X equals less or equal than 19. There's a rule in your textbook that they mention about this. I want to show you this really quick. That's right here, right? So this is if X is a continuous random variable for any X1, X2, this holds true. So I'm gonna use this rule specifically, okay? This one right here, okay? I'm gonna use this to solve those problems, okay? So let's go back to that. So this is 10 less than the random variable X, which is less or equal than 19. This means that X is less than 19 minus X less than 10. You know what's X less than 19, that's given here, right? Let me make this a little thicker. So that's here, right here, 19, right? This one right here is 0.7. And minus less than 10, that means this one right here, right? Because less than 10 means X is less or equal than 9, right? Because we're not counting this is the same as this because here X is not included, right? So that's the same as that. So that's 0.4, right? So this is 0.3. That's it. That's all you have to do. The next one, I use the same trick. So Px less than 29 minus X less than 20. Okay. And you get your answer for that one, right? So let me move this on the top. And after that, we have more room to do this. Okay. Okay. So less than 29, that means this one. Yes, which is 0.8. And less than 20 means this one, right? Because less than 20 is not counting 20, so it's from 0 to 19 basically. So this is 0.7, 0.1. Next, the other one, they said more than 39 visitors, right? So that means 1 minus the probability of x is less or equal than 39. You have the probability that is right here, right? So that's 0.9, 0.1. Done, right? Next, they're asking you for this problem, the thickness of a conductive coating, micrometers, has a density, blah, 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 blah. Determine the mean and the variance of the coating thickness. If the coating costs 50 cents per micrometer of thickness on each part, what is the average cost of the coating per part? Okay, so next we need to find, they give us a continuous variable, right? So they give us the density function. So they want us to calculate the expectation and the variance of this continuous variable, right? Okay, so we need to find the expectation. I think I did that here. 7 here. I'm gonna start from scratch. Okay, so don't worry about if you don't get it first. It's very easy, by the way. It's not difficult. So this is the problem. So first of all, I have a piecewise function, right? They're saying that I can use this function when this is 100 micrometers, between 100 and 120 micrometers, right? So for simplicity, I'm just gonna put 100 and 120, okay? You know that it's micrometers and 120 micrometers and 100 micrometers. And then 0 elsewhere, right? Okay. So they want me to calculate the mean, the expectation. So this is by definition the integral from negative infinity to infinity x f of x dx. Yes, that's by definition. So here expectation then equals the integral from 100 to 200, 100 to 120 x 600 x to the negative 2 dx. So this is going to be 600 x to the negative 1 integral from 100 to 120 dx. So this is 600 ln x from 100 to 120, right? And this is the expectation. And just need to plug it in, right? 120 minus ln 100 and multiply by that, and we get the expectation. So the expectation equals ln 120 ln 120 minus ln 100 times 600, you get 109.3929. Done. Now you need to calculate the integral, right? So I'm sorry, not the integral, the variance. You need to do the variance of this function, this density function, right? So the variance, you know, by definition is the integral from negative infinity to infinity, x minus mu square times the function dx. If you do it in this format, it's going to be difficult to integrate. So you're going to use this. You know that the variance equals the expectation square minus the expectation, I'm sorry, right? So this is the variance. But because we already calculate this part, right, from this part right here, you just need to square that, right? You need to square that. We can just solve for that. So this is basically the variance equals the integral of the expectation square, right? So we can just plug that here, basically, and we get the integral from negative infinity to infinity, x squared f of x dx minus the expectation, everything quantity square, right? So we just need to integrate, right? So bx equals from 100 to 120, x squared, the function is 600 x to the negative 2 dx minus the expectation, which is 109.3929, everything is squared, and then we compute, right? So sorry about that. So compute. So this is equal to 600x from 100 to 200, 100 to 120, minus 109.3929 square. So this is what is this? 72,000 minus 60,000 minus 109.3929 second power. So this is 12,000 minus whatever this is, right? So this is 109 squared. That's 11,966.8140, right? And 12,000 minus that number, we get 33.19. So this is the variance. Now, that's it. That's all you need to do. You have the expectation, the variance. They're asking one more thing, right? They want you to find if the coating cost is 50 cents per micrometer of thickness. Oh, I forgot. Don't forget your units, right? So micrometers here, and this is going to be micrometer squared. And if the coating cost is 50 cents per micrometer of thickness on each part, what is the average cost? So the average cost is what? The 50 cents, right? Times the mean, right? Or the expectation here, 109.3929. When you multiply that, you get the result, right? So 109.3929 times 50 cents, you get 54.70 cents. So that's the average cost. Okay, so this is part B, and that was part A. Okay, that's it. Next question is asking for the tensile 4. That's another question, right? So 4, the tensile strength. Okay, I think I did this here somewhere. The tensile strength. Yeah. I'm gonna keep the graph. Actually, I don't like this graph. I don't like the color. Okay. Okay. Okay, the tensile strength of paper is molded by a normal distribution. So this random variable follows a normal distribution with mean mu and standard deviation sigma. Okay, so that's the notation that you use when the random variable follows a normal distribution, right? Yeah, so they said that the normal distribution, so this variable follows a normal distribution with mean 35. This stands for the mean, right? This is the mean right here. And the standard deviation is 2, right? So that's the standard deviation right here. So this is 2, right? And what is the probability that the strength of a sample is less than 39? So probability that is less than 39, right? So you need to standardize. Why we need to standardize? Because we don't know the probability. Like in the previous problems, like when you have a PMF, the probability mass function, they give us the probability, right? They give you the value, the X value, and its probability. Here we don't have the probability. So the only way to find out what is the probability of this is by standardizing, right? So standardizing, you need to use this formula. X, the C value equals X minus mu over sigma, okay? And when you standardizing, then you will use a table called the C table or the standard normal distribution table, and you will find the value of that probability that you're looking for. So here, the probability of X is less than 39. We don't know right now, but once we standardize it, we will know. So this is 39, that's the X value. The mu is the mean, 35 over the standard deviation is 2, right? So this is going to be 4 over 2. So there's going to be 2, right? So this is C less than 2, right? But just remember this, the table gives you the area to the left, right? So the area to the left, it will be the probability that you're looking for. So at this point, I can use the table. So if I go C equals 2, that's here somewhere. C equals 2, that's right here. C equals 2. So it's 0.9773. 0.9773. So this is 0.9773. 97, 73. So at that point, or 7 to 5, you're done. That's it. That's the only thing you need to do. Okay. Intuitively, right? Intuitively, you can find this area too. Like you can say, you know that the distribution, it's normal. So what are the properties of a normal distribution? You have to remember that. Well, the mean equals the mode equals the median. You have to remember that, right? What else? This is symmetric, right? So the area to the left from the mean equals the area to the right of the mean. So these are symmetrical. So, and remember the area is 1, right? So that means that this is the area is 0.5 here, and this area is 0.5. The area always equal to 1 or 100%, right? Now, those are some properties. You have to remember that when you transform, or when you standardize the normal distribution into a standard normal distribution, the mean is 0, and one standard deviation above the mean and one standard deviation below the mean. This is called the empirical rule, right? The empirical rule states this. The empirical rule states this. One standard deviation above is 1, one standard deviation below is -1, so that's 68% of the area. So that means that these cover 68% of the area. And then 2 standard deviations, or 2 standard deviation below the mean, 2 standard deviation above the mean covers 95% of the area. So that means the thing I'm gonna color in green, that's gonna be 95%. So the yellow bar and this bar covers 95%. So you can see what's happening. And then 3 standard deviations below the mean, 3 standard deviations above the mean covers 99 point. Let me cover this thing. So this part in blue, that part in blue covers 99.7, okay, or 99.75%, okay. So this is called the empirical rule, and that's what it does. So when I was telling you about you could answer part A intuitively, well, if you know that there's 2 standard deviations below 2, right? So we are above, we are 2 standard deviations above 2. We're talking about this number, right? We're talking about this number right here. So that means we know that from -2 to 2, right? Or 2 standard deviation below the mean and 2 standard deviation above the mean, that's just 95%. So that means if I add this tail right here, I should get the total area, right? So if that's 95%, you have 5% remaining. So this is 2.5% here in this tail and 2.5% in this tail, right? Talking about this part and this part, right? So if you add the 95% plus a 2.5%, remember the C table gives you the area to the left, right? So basically what we're getting as a result, we're getting the area to the left of this, right? So if you add that, you get a 95 plus 2.5, that would be 97.5, which is close to this, right? 0.97, 0.997, right? Something about that. So that's the point. You need to add that 95 plus 2.5, you get 97, 2.5, right? About that, something about that. You can add it, right? 97, 95 plus 0.25, right? So that's 2%. Yeah, that would be about there. And then you add these things and you get this thing, right? So that's close to the number that we get with the table. So that's what I'm saying intuitively. You don't need to do this if this is confusing. Just do the way I show you with the table, and that's it, right? But that's the concept, right, behind it. Okay, done with that. And next question is B. They're asking you, if the specifications require the tensile strength to exceed 29, so the probability of X less than 20, right, 29, what is the proportion of the samples scrapped? So we need to standardize again. 29 minus the mean, this is the C-score, is 29 minus 35 over the standard deviation of 2. This is going to be -6 over 2. That's going to be -3. So this is probability of C less than -3, right? And at this point, you can just look at the table, right? And then you get your answer. So -3, I will give you this table on the test. Okay, -3, -3, here, -3. So this is area. This one right here. This is the area, -3. 0.0013. Point 0.0013. Done. That's it. You're done. Absolutely done. That's all you have to do. Okay, next question. 5. Operators of medical linear. Okay, let me see if I have that. I already copied that. Yeah, here it is. Okay. So here they're asking you. Okay, they said operators of a medical linear accelerator are interested in estimating the numbers of hours until the first software failure, right? Prior experience has shown that the time until failure is normally distributed. So this random variable follows a normal distribution with mean, mu, and sigma, standard deviation, sigma, right? Okay, so this random variable follows a normal distribution. The mean is 1,000 hours. They said that here. The standard deviation is 60. So find a probability that the software will not fail before. Will not fail before that time. So it's gonna be above that time, basically, right? Because it will not fail before that. So after that can fail. So yeah, we need to standardize it, right? So the C value, because they say it follows a normal distribution. We don't have this probability, so we need to use the standard normal distribution. So 1140 minus 1,000 over sigma 60. So this is 140 over 60, cancel. This is 7 over 3. So this is going to be 2/3, right? 2 1/3. So this is 2.33. So this is C greater than 2.33, right? That's what we got. And we don't have the area to the right of the C value. Remember, the standard normal distribution just give you the area to the left, right? So like this, right? So we need to adjust something, right? So this is going to be 1 minus the probability of C less than 2.33, right? Okay, so if we do that, these are one of the properties of the normal distribution, okay? So if you see something like greater, you need always to do less, because remember the area give you, the standard normal distribution give you the area to the left, doesn't have to the right, right? So just in case, if you want to recall this, if they give you something like this, C -1.33, you can find the table because the table has the negative values, but in reality, you should transform it, right? You should say, okay, this is C greater or equal than 1.33, and then you should say 1 minus C less or equal than 1.33. You should do that in reality, but since you have the negative value here, no problem. In the table, you have the negative value, so you don't need to worry about that. But here, I couldn't do it that way because the inequality is to the, it says greater, and it has to be always less than, because we need the area to the left. Okay, that being said, I just need to calculate the 2.33, right? 1 minus 2.33, 2.33, that's positive 2.33, 2.33. That's right here, 2.33. That's how you find it, 2.3, and 33 is this value, right? 2.33. You need to add, just in case you don't know what I'm doing, you need to add this and this, right? So that means that this is 2.3 plus 0.33, 0.03. That gives you 2.33, right? If you're confused, okay? So that area is 0.9901. 0.9901. So this is 1 minus 0.9901. So if you subtract that, you get 0.0099. That's it. That's the end of that part. Part B. Find the probability that the software will fail within 900 hours. So within 900 hours means this thing. Okay. And then this means that this is one. Not actually, we need to standardize it, right? So 900 minus the mean. So this is a C-score over 60. So this is going to be negative 100 over 60. Cancel, cancel. Negative 5 over 3. It's going to be negative 1 2/3. I'm not wrong. So this is negative 1.66. So this is the probability of C is less than negative 1.66. So since the value is to the left, so I can just use the table and get my answer, right? So when you do the table, negative 1.66, so you look here, negative 1.66. So that's right here, negative 1.66. 1.66. That's right here. This is right here. So this is the area. You just need to right. So this is negative 1.6, and this is 0.06, and this is negative 1.66, and the area is 0.0485. 0.0485. About that, right? We double check. 0.0485. Yeah, about that. Okay, that's it. We're done, right? That's all you have to do. The other part, the other questions, I'm gonna do it in another video because when I record it, it doesn't allow me to record more than certain amount of minutes. So that's it. I'm gonna post this to you guys. Thank you.